One of the fastest growing segments in the yachting industry right now is that of explorer yachts. Whether people really want to explore the world or whether they just like that greater volume and longer range of an explorer yacht, it seems that yacht owners just can't get enough of them. Now, one company that is really supplying that demand for modern designed explorer yachts is Numarine, based here close to Istanbul in Turkey. But behind the glamour and the glitz of luxury explorer yachts, there's a real industry of cutting metal and welding hulls together, of making cabinetry, installing it on board, of laying up fiberglass for the hulls as well. We got exclusive access to the Numarine shipyard to be able to show you from beginning to end how these yachts are put together. And in fact, in this series of videos, we'll be following the construction of a 37-meter XP, which is a steel hull and composite superstructure, and a 30 XP, which is a brand new model built completely from GRP. So join me and let's meet the people who build these yachts. And we start with the CEO and founder of Numarine, Ömer Malaz. I asked him about his new project, the 30 XP, and I was surprised to learn that it had a propulsion system that's very different to the other models in the range.
Well, 30 XP is gonna be our most revolutionary design ever because we are going for diesel electric to begin with. And it's gonna be powered by 418 kilowatt generators, producing electricity for 2 large electrical motors, which is gonna be turning the props. This has advantage because generators are usually more efficient than diesel engines. Plus, you don't have to have 2 main engines and 2 generators. With having 4 smaller generators, we can have the versatility to cruise slow speed with only single generator, or full speed with 4 generators running, or it will have the solar energy and it will have the, how shall I say, lithium-ion battery pack, 200 kilowatts, to give you generator-free life on board when at anchor. So that's one feature it will have. The second feature, we're having a lot of fold-down balconies, and we have a huge beach club because of 3 fold-down platforms. And that's something new. We've never done it. I have not seen it being done on a 30-meter level. So that will be very, very different. And the styling-wise, it's again a typical Numarine, but we just push the design envelope a little bit further. Well, we'll have one owner balcony, owner master cabin balcony private to him. And then we'll have 3 folding down platform on the beach club area, which is a 47 square meter beach club. On a 30-meter boat, that's unheard of. And because we are able to push the engine room further and smaller because of diesel electric package, we're able to give all that space to the beach club. We're getting a tender garage for 6.25 meter Williams diesel tender. This way they will be able to refill the diesel from the boat's tank, which is also a big advantage on the big boats.
When Ömer believes that it's time to release a new model, he calls together key members of his team to discuss the project and to start to put the wheels into motion. Englishman Malcolm Hutchinson is the technical director of Numarine, and he shed light on the birth of the Numarine 30 XP and also on their decision to build in GRP rather than steel.
The 30 was, straight out of Ömer's imagination. Usually that's how our designs start. He looks around, sees other boats and thinks, I want something like this, and comes up with an idea which he works on with our designer, our Jan Yalman, our aesthetics designer first. They come up with the design lines and how they want it to look and the sort of ideas, and then it gets thrown at me to say, can we do this? Can we make it work? Usually that design is 85% doable without any questions. And then the 15% of tidying up and finishing is something that we work on together. And I would say most of the time the final aesthetics don't change. It's just how we achieve it that gets modified. The choice for composite on the 30 was based on the perception we have where the yacht will be used, how it will be used, also the sales volumes that will be involved, and our manufacturing facilities. So it's on a crossover. The 30 for me is a crossover. It could be steel, it could be GRP, but one thing that we wanted to produce was a very ecologically friendly boat, so it has to be energy efficient, and we're able to achieve that lighter weight vessel in GRP, which enables smaller engines to be more efficient running. So that, I think, was the primary drive to stay with GRP at that size.
Malcolm works hand in hand with Murat San, the factory director. It's his job to ensure that the design of a new yacht becomes reality. GRP yacht construction is a fascinating field, since a GRP yacht is made in a mould, or more accurately, a number of moulds. So before you can start anything at all, you have to make the moulds themselves, and to make a mould, you have to have a plug. Anyway, Murat can do a better job of explaining the process.
Design-wise, we run it with two ways. One is hull performance design, which is mostly about the bottom shape of the hull, because you have performance expectations. And visually, it has a visual design. We are doing the engineering study of the hull with Umberto Tagliavini in Italy, and we are doing our visual design with Can Yanvan. So these two talks together, and they know what to start, when to deliver what. So it's all starting with the project plan. So we expect the final design of the hull, which is bottom and top sides, to put together and will be delivered to us as a final design, which will be our start point. There, our engineering is taking the 3D design of the hull, because we have size limitation in our 5X machine, which is 8 meter wide, 12 meter long, and 5 meter height, let's say. So we have limitations. So we have to slice the model into the size as much as we can. Of course, we want as less as possible. For example, on 30XP, we have 9 parts to put together. So we start with Strafor foam. We machine the foam first, and then we put a protection layer, which is a lamination, and then we'll put model paste on top. Then that is our final model to be machined under CNC. Then we start final machining. Then after we finished machining, we have the first part of the plaque. Like this, we process 9 parts together, and then it has metal construction to be done on the plaque, because we will put them on top of each other, back of each other, in the middle of somewhere. So it has to have a perfect metal construction, because when you put things together, it should only be welding. I can say for 30XP, it took 3 months to machine all these 9 parts and put them together. And now we planned another 2 months to fare the plaque, because you put 9 parts together, of course you will need some fairing work on the joints. So we are now working on the fairing, which we are planning a month. Then another 1 month or 1.5 months to take the mold out of it, which will be layers of laminations on top. Then we will release the mold from the plaque. It will be our proper mold. We will check the surface of it. If it's needed, we will repair, we will polish, and it will be ready for the hull lamination start, which is our production start. So we plan another, for the first boat, a year to do the first boat. When it becomes a serial line, our plan is to build a 30 XP in 10 months. And our capacity is to do 330 XPs in a year.
We'll be following the construction of the Numarine 30 XP as she takes place over the next year. But Numarine also have a very successful range of 37-metre yachts called the 37 XP. Omer told me both about the success of this model and also some of her characteristics.
To begin with, we have sold a total of 16 units so far. And 37 is a derivative of the original 32 XP, which was already a very successful model. But the moment 37 came in the play, 32 really ceased to exist because it looks better, it's a better seagoing, and it offers considerable amount of space, more compared to 32, for really minuscule amount of price difference. And we've managed to sell, like I said, 16 of those. And as we speak today, we have 5 under construction. Our number one feature is we can get to carry a large tender. On the upper deck, we have a huge crane, 3-ton crane, which is able to lift up to 9-meter tender, as well as a second tender, a jet ski, a quad. Really, there's so much versatility there. And I think that gives our customer a big range. Once the boat is stationary at anchor, they have a wide range to go across the seas with a 9.5 meter tender. It's a huge tender to begin with. And I think that is our number one selling point. And most of our clients chose to have a large tender. On a typical 37 meters, you would get 5.5, maybe 6 meter tender. 9 meters is a completely different ballgame. That plus, we have a large owner or another second salon, cigar room upstairs on the top deck. It can be configured between 5, 6, or 7 cabin versions. So we have quite a lot of versatility.
A distinctive feature of the 37 XP is that whilst her hull is steel, her superstructure is made from GRP. I asked Omer about this choice.
Yeah, the benefits of GRP over steel is, of course, rapidity. The moment you have the mold ready, the GRP you get to produce one every 2 months maximum, maybe once every a month and a half when we are talking 30 meters. On the other hand, steel is steel. Of course, it's a much stronger material, but with steel you have to start with scratch every time. Scratch means starting laying the keel and putting the foundations, and once that's done, you have to go through the paint process, which is a long and really dusty and dirty process. For those reasons, GRP is so much more quick, faster, and really just as reliable. We are a composite boat manufacturer at the end of the day. So we do have a CNC machine, 5-axis CNC machine. We make our own molds, and making molds for us is quite easy. And we knew we were going to produce more than 132 or 37, and in the future 45. So if you're going to make more than one, then having some sort of mold actually is very efficient way of producing it. So that's the reason we chose composite over aluminum on the larger series, let's say.
The material choices for the 37 with the steel GRP combination was based around the durability, reliability of a steel hull, which when you're getting into the 30 meter plus class, I think, especially as an explorer yacht, people want to make sure that she's robust and that she will go where you say she'll go. So steel makes them feel better. Traditionally, I suppose other yards use aluminium as a superstructure, and there aren't many people that are using GRP, but we as a GRP manufacturer are far more experienced and able with the GRP side as well. So making that steel GRP combination for us was a natural choice. For the yacht, it also removes the electrolysis issues that you can get between dissimilar metals. So we don't have to worry about that. Our concern is just the bonding issue, which we got over very well with flange and the correct bonding materials. We're using a very simple flange mounting assembly. On the steel, we have a T-flange and an L-flange on the fiberglass top sections. They're then bolted and bonded with a structural adhesive together to produce a hidden joint that is very robust and with a little bit of elasticity in it, so that it's not likely to crack and leak.
From Murat's perspective, the construction of a steel and composite yacht presents very different challenges to an all-composite yacht, and the build process is very different too. He explained it to me.
37 is a steel boat. We started with 32 XP first, then we started 37, and steel was something new to us. So like automotive industry is doing, we just tried to choose the best supplier to us, because we said we are not going to do this steel in-house. So we tried to find the best project manager and the supplier who can deliver us a perfect product, which is the steel hull for us. On 32s and 37s, we have 5-6 cabin options. Depending on which one is going to be chosen, the structure changes. So before we start, we need to know the layout first. After we know this, we send all this information to the project manager who is working with a nesting guy. Nesting is, think about our steel plates are 2 meter wide and 8 meter length, and of course we want to use it the most efficient way. The waste should be minimum as possible. So nesting guy is working on the layout to use the steel most efficient way for the least or minimum amount of waste. And these nesting drawings are sent to the supplier who has the laser cutting machine in-house as well. And then we start with cutting. Then the first step of the production is laying the deck floor on the jig. So we put the plates together, which becomes our deck floor first. On the other hand, parallel to that, the bulkheads and the other bits are being produced. But like the limber holes and the passages, they are not being cut in place. It's all coming out of nesting. So we have lots of parallel production going to the deck plating. So once the deck plating is done, then we put the bulkheads, structural bulkheads on top. Then we have something looking like a boat. Then we cover them with the plates. Then after we finish this covering, the piece, which I will call as hull gets together and it is time to roll. From scratch to the sandblasting, normally we plan 6 months. The first 4 months is getting, main deck plating, welding together, covering, and the rolling is becoming on the 4th month, at the end of 4th month. After we roll, we have another 2 months to go, where we have, we call it as 102 block, but I will call it as main deck, steel structure. Before we roll the hull, parallel, we already have main deck welded together and ready to go on. So after we roll the boat, the first thing we do is putting the main deck steel structure on top and start welding it together. So this takes another, let's say, 2 months. Within these 2 months, it's not only the main deck welding, of course the other bit inside is happening. So I will say this will take average 6 months. And after this is done, we have the scaffolding around and tent covering, so it's ready to sandblast.
Of course, there's a lot more to building a yacht than just making the hulls and the superstructures. They have to be fitted out to a standard that's worthy of a luxury home, together with air conditioning, AV systems, kitchen appliances. Then they have to be fitted with engines, generators, fuel tanks, and somehow made to be able to navigate through rough seas in a way that causes the minimum of noise and vibration possible. Luxury yachts built by Numarine are an absolute tribute to modern engineering and modern production techniques. So we'll be coming back in a few months to see how they're getting on with those two specific models that we looked at and how it is that they put them together. Bing.